This lesson will cover function notation. The learning goal is to understand function notation, and success criteria is you can understand what function notation represents, and you can find values for dependent and independent variables. So function notation is used when writing the equation of a function. It is most helpful to use function notation when looking at more than one function at the same time in order to easily identify what function is being referenced. Now we can choose any letter for this, but often letters F, G, and H are used first. So for example, given the following graph, determine the y value when x is 1. And that's where function notation comes in handy, because here we have two graphs. We have a quadratic function and we have a linear function. Now when x is equal to 1, it appears that on our linear function, y is equal to -1, and on our quadratic function, y is equal to -3. Now we want to efficiently say that these functions are equal to these values, and we want to use that, and we want to do it in such a way that it's quick to identify, and we do that by labeling. Instead of using, for instance, we might say y equals the quadratic function form, and write out the full function or the full equation. We're still going to do this. We're going to say that this quadratic function is f of x, and this linear function is g of x. So we kind of say it's a function of x. And function notation then states what an independent variable is. Whatever variable is within the bracket here, that's your independent. So normally that's going to be x, and in some cases you'll see t for time, or you might see other variables representing different contexts and depending on the situation. So for example, instead of writing y equals -3, x plus 2 squared minus 4, we are instead just going to write this. F of x equals -3, x plus 2 squared minus 4. Same thing, instead of y, it's an f of x. It's a very small change in how we write functions, but it does come in handy in the long run when we start looking at a lot of different functions at the same time. So f of x is the most common form you'll see. You'll see g of x, like we just saw above, h of x, and many others. Now just note that this f of x is notation. It is not a multiplication between f and x. It is a function of x. We might say it's a function f of x. So how do we use this, or how does this come to play when we're looking at different values? So for example, we're going to be given the functions f of x equals -3, x plus 2 squared minus 4, and g of x equals 3x plus 1. We're going to determine what f of 0 is, and then what does this represent. So really what this is saying is our x value is 0. So f of 0 is the same thing as saying x equals 0. So you would substitute 0 into your equation. And we write it like this. You say f of 0 is equal to -3, 0, plus 2 squared minus 4. And then you would just go ahead and simplify. That's equal to -3. That's 2 squared minus 4. That's equal to -3 minus 4 minus 4. And then that's equal to -3 times 4 is -12 minus 4 is -16. So this right here, this represents when x is 0, y is 16. It gives us a point. So therefore, 0, -16 is a point of our function f of x equals -3 x plus 2 squared minus 4. Now we have what value of x allows g of x equal to negative 4 was to represent. So in this case, let's put this anyway. Instead of being given the value of x, we're told when the function is equal to negative 4. So g of x equal to 3x plus 1. This is essentially saying, it's the same thing as saying y equals negative 4. What does x equal? That's what it's asking here. And we can solve for x this way. So g of x is negative 4. G of x is itself equal to 3x plus 1. And then we just solve for x. So that gives us negative 5 equals 3x. And x is equal to negative 5 over 3. And this also gives us a point. So therefore, this is x of negative 5 over 3. So negative 5 over 3, negative 4 is a point on g of x. And we don't have to write the full function here. We could just say g of x. That's what's nice about this. So you can literally just say g of x, f of x, and state the function's kind of name. Now finally, we're going to determine f of a minus 1. So you're not always going to be encountering just a value that you're going to substitute in. It might be in a function itself, an equation itself. So we know that f of x is equal to negative 3 x plus 2 squared minus 4. And in this case, we're being told that x is equal to a minus 1. So we're going to substitute x equals a minus 1 into our function. And then simplify. So this is, or I have to change this x actually, sorry, to a minus 1 to show substitution. Let's do another step for that. So f of a minus 1 is equal to negative 3. Then we have to substitute a minus 1 for x plus 2 squared minus 4. And then negative 3. So we have a minus 1 plus 2, so that's going to be a plus 1 squared minus 4. We would then have to expand this bracket, so that's going to give us negative 3 to have a plus 1, a plus 1. Minus 4. You would then expand and simplify here. So negative 3, that would give us at the end a squared plus 2a, that's an x. 2a plus 1 minus 4. Let's move this up here now. And then we'd have to distribute the negative 3 and subtract 4. So that would give us negative 3a squared minus 6a minus 3 minus 4. And finally, f of a minus 1 would be equal to negative 3a squared minus 6a minus 7. So we might use this later if we're told that the value of a is some of the value. We then substitute that into there and figure out what that is. So this, what we've just done, this is kind of like a combination of functions. So function notation, it's a different way of representing functions. It allows for a quick identification of a function, and it's very similar to what we've been doing with y equals some variation of x, but now using function notation instead.